So in this video, we'll be covering the coding part of it. That is how to fix those numeric vulnerabilities that you introduce accidentally using integers. Namely, right, divide by zero error, integer truncation error, and integer overflow, and incorrect conversion, and then numeric range comparison check. Okay, let's start with the divided by zero error. Right? So it's a very common one and very easy to understand as well. Now, when you take a look at this code, right? So what do we have it here? So I've initialized output integer variable to -1, and then I'm performing a division operation here, right? And I'm taking the user input, which is the case most likely where we don't interpret that and make a mistake. Now, so you are asking the user to enter numerator and the denominator, and if the denominator is 0, and it will be thrown an exception. Then what happens? Let's just quickly run and see what is going to come. So now it is asking, please enter the integer numerator. So I enter 5, and the denominator I enter 0. What happened? So it is an exception. An exception occurred, and then the program couldn't continue. The program got terminated. That's an important thing to remember. So what happens when you hit the divide by zero error? Your entire application gets stopped. So your application stopped providing the service. If you are running an enterprise level application, your entire application goes down because you didn't handle this. Now let's look into the fix code. So now I'm switched to the fix code. So here you see the same output is initialized to -1, and then I have a numerator denominator to be received from user. What I have added here is a try block. So the division operation, which I'm unsure about what input will come, and I want it to be handled gracefully. Now the catch block catches that error, and then it continues. The program continues to run. Right? So let's check. I'm running the program, and it's asking enter the numerator. Again, I enter 5, and enter the denominator. I enter 0. You see, so there is an arithmetic exception that happened, which is divide by zero arithmetic exception. And now I continue to print the value, which is -1, the initial value, and then there is a print statement, divide by zero error demo ends here. So the program continued, your application, your enterprise service didn't get interrupted, right? So when you handle this gracefully, what happens? You know the value of it now. And now this is one way of doing it. You can also make a check that input 2 could never be 0. So you can make a condition only if input 2 is not equal to 0, get into the execution statement. That's another way of fixing it. Well, here is the second one about the truncation. Truncation is equally simple to understand, and it's common to make a mistake. Now, let's see. So here I'm receiving an integer from the user, which is stored in integer. And then I'm storing this integer into a short integer, which is typically 2 bytes, whereas integer 4 bytes. Now, let's see what happens. So I'm running the program, and it's asking me enter the number. So I enter 5. The value of the conversion is 5. Nothing wrong, right? Because 5 could also be stored in short integer. Now let me try again, which is a bigger number than what a short integer can hold, right? So 768. Yeah, I entered a positive integer, and it prints a negative integer because it couldn't hold in the short integer. Now let me give even a bigger number, right? See what happens when it truncates. The value becomes completely undetermined. See, now you couldn't handle it. This goes back to your exception handling as well. So where you couldn't handle the large number to be stored into integer, right? So this is not being handled by an integer itself. So this exception thrown. Now you could handle that using a try block. And now let me enter something that the integer could hold, but short integer cannot. See this, what happened? I've entered what integer could hold, but converted to 9, right? So this is what happens. Completely undetermined output. You cannot know what is going to come out. And these, we think, okay, I'm saving 2 bytes here, but you're forgetting the value is coming from unknown sources. You don't know. You don't have the control over the source from which the data comes in. So therefore, either you write a condition that is limits. So let's look into the fixes, right? So what I did, so here, if the input should always be less than max value that a short could hold, only then I accept it. Therefore, I prevent the conversion. Right? Let's run it and see. Now I have entered here 32,007, 3,27,689. I'll enter the same input here too to check what happens. Oh, this is strange. If input is less than short's max value, isn't it less than? It is. Am I not running the same one? Yeah. So earlier the previous file was run. So now you see this. Let me rerun again. So here I enter the same number that I have entered previously. You see this. Now, at least I'm predictable. I know I'm not going to allow this number, which I can't store it in short integer. So this is how you prevent the truncation slash overflow errors, right? So either it gets truncated or it gets overflown. Now, always check the max value that an integer variable could hold. This is applicable to all other data types as well. So you have the standard definitions of all data types max value and min value. Always leverage them in your code so that your code is going to be secure and you don't introduce any vulnerabilities into your code. Here is another example. Now this demonstrates a real time example, right? So where you are calculating a salary, right, based on every quarter, and you sum them up to show the user what is his annual salary. Now in this example, so what I'm doing, enter the salary for first quarter, second quarter, third quarter, fourth quarter, and storing them in short integer, assuming that the salary would not increase the limit of short, that is the max value of short. And unfortunately, what I'm doing is I'm summing them up and storing it in another short. Now, which could have been accidental, right? So I've been declaring short input one, input two, input three, and then I continue to copy paste that, which is typically the case, right? Don't you agree with this? We typically copy paste the code, which is thinking, okay, this is the same data type. Okay, let me not type it. Let me copy paste it. So and then you print his salary. Let's see what comes out as an answer is annual salary, right? So I enter the short number could hold right 10. I'll also say 10,000 as a first quarter salary, and then I enter second quarter salary, enter third quarter, enter fourth quarter. You see, it's surprise. So it is supposed to be 40,000, but what has come up is a negative number. This is what happens when it overflows. Well, so let's see the fix for this. The fix is you declare a long variable when you know that your data type is not going to be the same, right? So you declare a longer variable that could hold, because all these are short, and when you combine all the shorts, the max value could be long. Well, now let's look into the range comparison check, numeric range comparison check. Okay, so here I'm doing a simple operation. This is a bank account transaction. So I'm depositing some amount and withdrawing some amount. So I'm depositing 1,000 here. Okay, and then withdrawing 300. Then the balance should be 700. So I'm showing the balance. And then see, I'm allowing here to withdraw minus 90, and then check what is the value that you will get when you actually show the balance. Let me run it and see. Yeah, this is so it's good, right? So you withdraw minus 90, yet your balance is 790. What is happening here? Now let's go and check it. So here I have a maximum withdrawal limit 350, and I have the account balance being initialized to 0. Now initially you deposited 1,000, so the account balance gets added to 1,000, and then you withdraw. If the withdrawal amount is should always be less than 350, okay, then what am I doing? You minus the withdrawal amount from the account balance, isn't it? It's fair. It looks very much right in the beginning. Now, then what is happening here, right? So the minus 90, when you pass it to withdraw, and your withdrawal amount minus 90 is less than 350, so the condition is passed, and you come in and you are minusing, that is subtracting minus 90 from withdrawal, so which is minus into minus plus, so it becomes 790. Now, the bank account holder will be super happy, isn't it? So now what is the fix for this? So not just the maximum limit, but also you should check it minimum limit, right? So minimum withdrawal limit should always be greater than 0. Only then you perform the same operation. But the condition was missing earlier, right? So you should compare the ranges and then do it. So this is also another common one what we do. Now let me run it and see. So yeah, it's good. Invalid withdrawal limit when you enter minus 90. So therefore, the new balance is also 700, which is correct, right? So this is another common one where we don't think the other side of logic, right? Okay, this could also be possible. So all of them becomes the numeric incorrect range comparisons, which would lead to financial losses. Well, hope you have understood the errors code and as well as the fixes. So this is how you write insecure code. On the other side, that is how you write the secure code. They are very simple mistake, very common to do, and how they cause catastrophic errors, financial losses, right? Medical record errors, which make the decisions for people's lives, right? So always encourage secure coding and make sure you keep these things in mind. Thank you for watching. Do subscribe and mention your comments so that I can make better videos. I can make videos on the topic that you would like to watch. So please do leave a comment. Thank you for watching.